Okay, today, last thing we have to learn before we take our test is piecewise functions. And technically, they're called piecewise, but I like to call them Franken functions because they are a blend of like Frankenstein had a head from one body and sewn onto the body from a different body and the arms from a different body. This is one function, which then stops, and then a new function starts. And let's say it's a square root function for the next part, and then that stops, and then another function takes over and like goes down that way. And it's three separate functions. The question would be, as long as you don't screw up these endpoints, open here, closed here, let's say it's open here and closed there, that still passes the vertical line test, doesn't it? So how would you actually write out the equations for this? Well, you'd have three separate equations. And instead of just saying like y equals x squared for the parabola part, you have to have three different things. Y equals this sometimes, and this over here tells you when it's that. And it's this sometimes, let's say it's the absolute value function sometimes. And lastly, it's an equation that, let's say, goes through, it's having a slope of -1, so it's like negative x plus 10 some other times. Over here is the only thing that's really new to you, and that's saying this function only works between, and we usually say it in interval notation, like we'll say it's this first function from here to here, which is what? It's from -infinity to -4. And it's an empty spot right here, which means that on this red function, it doesn't get to own that spot at the end. This one's a closed-in dot. The parabola function owns that spot. So this one would go up until -4 and then stop working. So I'm using a parenthesis at -4. All right, and I just messed up because this part right here is actually the which part? The absolute value. So I should move all this down. So I will. Thank you. And it's okay to interrupt me on something like that. If you know I'm going off course, tell me. It's not your fault or anything. I'm just saying, feel free to interrupt. Yeah, I don't want to hear from you, though. All right. Peanut gallery out in the hallway. You guys know what that saying comes from? The peanut gallery. Have you heard of it before? No comments from the peanut gallery. Yes. All right. Don't have time today. All right. So then it's x squared. X squared is this parabola part, and then we would say where it's that parabola part. Now I just did this one really fast, so I think I'm gonna make my parabola look a little more professional here, because parabolas, if you're truly going to be x squared, at -3 it would be 9. At 2 or -2 it would be 4. At 1 it would be 1. At 0 it would be 0. At 1 it would be 1. At 2 it would be 4. At 3 it would be 9. And why am I putting an empty circle up there? Because that's already got that spot. So now I think it's important for you to understand that these borders are between the functions. These are super important. Like there's a borderline right there at x equals -4. That's super important. It's the border between where it's absolute value and where it's parabola time. Then there's another border that runs right along here. And that's at x equals 3. And that's where it switches from being a parabola to being a line that's just kind of heading downwards generally. All right, so this x squared function is only active between -4 and 3. So I'm going to put -4 to 3. Now this has got the solid dot here. So it owns -4. So I'm changing this to a bracket here at -4. And I'm going to say off the screen up here somewhere at 16 is where this thing would have had an empty circle, and then go down like this to there. All right, and so that one goes from -4, where it doesn't touch -4, to +3 over here, where it did not touch again. Then the last one has to go from 3 to, how far does it keep going till? Infinity. Now I just made a small mistake. Tell me where I wasn't careful. Yes, sir. Bracket on the 3, because this has a solid dot right there. All right, that is as complicated as they could get. Now, I'm going to go back and show you actually a simpler one, but I'm asking you to do it. Okay, so it's a function that could be anywhere from 2 to 3 is the most we would ever do, functions. And this area is called the domain. And it tells you where it is, that function. All right, so now I'm going to add a blank page, and I want you to find, I did make a nice clean graph later on in the lesson. If you want to use that, that would be fine for this. If you want to pull in, at some point I made you take a picture of a nice graph and throw it in your pictures file. If you want to insert picture right now and insert a graph, I just need you to have a clean graph to work on here. All right. So again, if you go to Notability and say insert picture, go to your pictures, you'll see I made you take a picture of a nice graph. Okay, so I want you to graph for me this Franken function. It is 3 things. Actually, let's just do 2. We're going to say it's going to be x squared from -infinity up until 3. And it owns 3, and it's going to be the absolute value of x from 3 to infinity. That is a piecewise function. It's defined in pieces. It's got 2 major pieces. Remember me saying the borderline is what's going to be really critical? I'm going to pull in a graph now from my notes. I'm going to pause for a second while I do. Okay. To start with, how many of you noticed that the 3, +3 here, was important, and put a line down there? If you haven't already, you should do that. It divides the 2 functions from each other. It is not a requirement, but I'll tell you, 9 times out of 10, when I mark these wrong on tests, it's because somebody screwed up the borderline. They had the function fine up until it was supposed to touch the other function. It's right where the borders are that you get all the trouble. Same's true in real life. While you're finishing this up, I had to sell a cabin this summer. And guess when we were selling the property and just about to have it all done, guess what happened? Borderline dispute. So all of a sudden, we've had these stakes in the ground for like 50 years of where the border is supposed to be between the 2 properties, and there was disagreement on that. Like, no, you don't own that, I own that. And it was the person who just moved in next door. Like, he hasn't ever been there. And all of a sudden, he thinks he owns. So anyway, I get it. Always comes down to the law, and it was going to have to be like fight it out with lawyers and stuff. And I was ick, not going to be fun. So we just basically, we signed an agreement to agree on where the new line would be, and had to pay money to get it done. But all we got done with, but it's always about the borders. It's always about the border lines. In Kashmir, have you heard of that area? Kashmir, it's the border between India and Pakistan, and they both think they own it. And so there's constant fighting over who owns Kashmir. It's a border right between the 2, and the scary part about that is that both countries have nukes. So when you have 2 countries that are fighting it out and they can get angry at each other and there's bloodshed, all of a sudden there's fear that somebody's going to, with nuclear armed players, you have to be very careful that somebody doesn't, turn it into a war over a border dispute. All right, so that border right there on the 3 separates the two functions. The left function is the x squared function. So I hope you knew how to make x squared. Now, if you forget how to make x squared, that it's a parabola that goes like this, but you're not actually sure where, you can make an xy chart. You're going to hear me say this a gazillion times in this class, that is your best friend in graphing, because when you forget or you're having trouble with a complicated one, you can always use an xy chart. So I'm going to stick in x is 0 and see what happens. It's this function I'm doing right now. So 0 squared is 0. So there we go. 0, 0 must be on my graph. I stick in a 1. 1 squared is 1. It's on my graph. Stick in a 2. 2 squared then. 2 squared is 4. 2 comma 4. And 3 comma 9. And there we go. Does it own that spot? Yes, it does. So now the left side, negative 1 goes in and I get 1. Negative 2 squared is 4. Negative 3 squared is 9. And then it goes off the graph, so I may as well stop there. So you want to do these all the way to the edge of the graph paper, so just kind of keep going there in general. Has an arrow on this end, does not have an arrow on that end because it stops right there. Okay. Next, we take over with the absolute value function. Here's where I normally draw the absolute value function, but what did I just do wrong? Across the border. Okay, I'm not allowed to be in that area. It only starts at 3. Okay, so it really only starts right there. And once again, all the troubles on the border, kids get like, oh, I'm glad I remembered that. What's wrong now? Has to be an open circle because it doesn't own 3. It's got a parenthesis right there. The other function owns 3. So I have an empty spot right here. How many of you think you could do that? Okay, good. So, could they be more complicated functions? Yes. These were pretty basic ones. Let's make it just a little more complicated, and I think you'll see why an XY chart might be handy. How about if we just do one more where it's y equals absolute value of 2x minus 1 from negative infinity up until negative 1. Doesn't own negative 1. And let's say it's x squared plus 3, or plus, let's actually make it minus 3 from negative 1 to infinity. All right, try making that Franken function, also known as a piecewise function. Pause while you give that one a shot. Okay, here we go. Should have, you know what, I'm going to pull in a graph. So which area did I say was the most important on the whole graph? Border. So the border's at negative 1. So I suggest that you have a dotted line running down here. You do not have to, I just think it helps. Next, I'm going to have the left side of it is going to be this part, and that's going to be absolute value of 2x minus 1. Ugh. Well, I know that it's supposed to be kind of like a line like this, but I'm not sure exactly where to go. How do I do that? XY chart. X, Y. Then I'm going to stick in some numbers for X. Now think about this. This tells me what the numbers for X can be. Even though I can't be negative 1, I'm going to stick in negative 1 because then I'll put an empty circle right there. That'll be a good place to start this one. I put in a negative 1 right here. I get negative 2 minus 1 makes negative 3. Absolute value of that is 3. Negative 1 comma 3. Do you get, I could put an empty circle right there, and my graph's going to look something like that. All right, good. Now, I'm going to find out a real point that's on it. Negative 2 would be on it. So if I put in a negative 2, that's going to become negative 4 minus 1 is negative 5. But then its absolute value of that makes it positive 5. So here is that one. And now I can draw a line through that and be confident I'd be heading the right direction. I could try another point if I wanted to. Negative 3. Negative 3 times 2 is negative 6 minus 1 is negative 7. Absolute value of that is 7. And there we go. Look at that. Okay, cool. So there's my left side. Raise your hand if you were doing that right. Okay, good. Now, the right side. The right side, I'm going to stick in -1 also, because this time -1 is owned by that function. So I'm making a new XY chart for this. And when I stick in -1, gives me -1 squared, which is 1. 1 minus 3 is -2. -1, -2. Down here. Weird. They don't have to match up at all. All right, so now, generally, you get this as a parabola, right? It's a parabola that's just been shifted down 3, so basically it's going to look kind of like that. Okay, now I just got to figure out exactly where, so I'm going to stick in some more points. I'm going to put in 0. If I put in 0, I get -3. Uh-oh. I'm going to double check this. Squared minus 3. Oh, I get it. First it has to go down a little bit before it goes back up. I was thinking I was wrong for a second, but nope, I'm I'm glad I checked those points, though, and didn't just kind of slap it in there. All right, 0, -3 is good. Then I'm going to put in +1. It's going to act just like -1, and it's going to get me -2, and that's here. And now it's going to keep going up. When I put in 2, it's going to give me 4 minus 3 is +1. 2 comma 1 is right there. So here we go. There. That's a piecewise function. Raise your hand if you feel like you got that. Okay, good. Then let's talk about everything else. So what did we do yesterday? One of the things we did yesterday was build a function. So here, build me a function that takes x and adds 7 first, and then multiplies by 9. Adds 7, and then multiplies by 9. And then, if you did it right, you'll have a function, which I want you to find f of x plus 2. Don't just put in x, put in x plus 2. First, make me the function. Then find f of x plus 2. I'll pause for a second while I give that a try. Okay, so let's see if you did it right. I have to make a function where x has 7 added to it, and then it's times by 9. True or false? False. Because why? The order's wrong. Make sure it does it what you say it does. First has to be +7. In this, it would be first is times 9. That forces it to be first. Now I've got it right. Now I can stick in x plus 2. Where? Instead of the x plus 7? No. Instead of the x. So I'm going to go 9 times, just replace the x with a parentheses. Remember me saying that? How the parentheses is so important? And now I can drop in x plus 2 in there. So now it's 9 times, can that be done? Yeah, I can add that together, x plus 9. And that makes it 9x plus 81. Either one of these is okay, but we do want you to simplify them down as far as you can. So that bottom one is the best, and then we get all the points. Raise your hand if you had that one. Okay, good. Next is domains. Here's a domain problem. It would be better if I do this. There. I want you to show me what the domain of this thing looks like on a number line. I gave you rules like, oh, on this kind, you take the under root and you set it this way. You take the denominator and you set it that way. And you put it all together on one number line. When you're all done, you're telling me what can you safely feed this function? What inputs can you safely put in? The question is not what crashes the function. The question is what is safe to feed the function. I'll pause while you try that one. So this one, you should have set this under root, I call it, greater than or equal to 0. 3x greater than or equal to 7, x greater than or equal to 7/3. Raise your hand if you had that part right. Good. Next part is the denominator has to be set not equal 0. Please don't set it equal to 0 and then say something like x equals 5. It's actually x is not equal to 5. And that's a big difference. We don't want it to be 5. So then we put these together, and this one is at 2 1/3. Here's 2 1/3, also known as 7/3. And it can be bigger than or equal to that. But wait, there's more. 5 hits right here. Can it be 5? No, it says not equal to 5. Should be an empty spot right there. And that's how you get your graph for the domain of that function. All right. Can they make it more complicated than that? Sure. The only thing that typically is done that makes it more complicated is, who remembers from yesterday? You could move the square root to the denominator. All right, so let me show you that. Let's try to solve it. What's the domain of that? You got rules. As long as you follow all the rules I told you, you'll still get this right. Okay, so what are all the rules I told you? I told you to take square roots and take the under root and set it greater than or equal to 0. Solve that, divide by 2. Wait a minute, 0 divided by 2? Yeah, that's okay, you can do that. X greater than or equal to 0. Done with one part, but that's only one part. The other part is the denominator rule. Take the denominator, not just the under root, the whole denominator, and set it not equal to 0. Okay, so now I got to go square both sides. Can I do that? Yeah, you can. Square this, square that. Square rooting brings you an absolute value on variables, but this is squaring, so it's okay. 0 squared is just 0. So then divide by 2, and it's still x is not equal to 0. But wait a minute, this one says not equal to 0, this one says does equal 0. If either one of them is poisonous, it's going to kill the function. So can I use 0 or not? No. So that's the key, is you have to have both of those things on the number line. This one would have said 0 is okay and bigger, but this one would say not 0, so I have to go back and put a hole right on top of 0, and now that was the correct answer. Okay. Yes? If you left it as this, you'd not be getting the right answer. You know why? Because the answer is, what are the things that work? And you have to say all real numbers except x cannot be 0. That I would accept, because that means you're saying everything that works instead of just saying everything that doesn't work. There's a difference. Yes, because this is complete. It doesn't have to say all the numbers. This is actually a much better answer because it includes all the numbers that are bigger than 0. And you'd have to say this x is not equal to 0 and comma x is greater than 0. There we go. I suppose you wouldn't have to have the not equal to 0 if you included just x is greater than 0. I guess that would work. But anyway, either way, I just know because I've graded lots of tests. The kids, if you do a number line, usually kids have the number line right, and then they somehow screw it up when they write the final answer if they don't use a number line. So just use a number line. Now, if they said you must put it in interval notation, then you'd have to write it. But I still would say make the number line and then just interpret it and go, okay, so let me think. That goes from 0 to infinity. Do I want brackets or parentheses? What do you think? Parentheses. So yeah, this would be interval notation for it. But it still start with a number line and then. All right, got more to learn. Next topic was, how do you tell if something's a function or not? Here's a picture. Function or not? Function, because it passes the vertical line test. Good. Here's some points. 2, 3, 3, 3, 4, 3. Function or not? Yes, it's a function. If you were not certain, I would encourage you to graph them and see if it passes the vertical line test. Here is 2, 3. Here's 3, 3. Here's 4, 3. Is that passing the vertical line test? Yeah, it's passing the vertical line test, and therefore it's a function. All right, what about now? 4, 5. Added to the group. 4, 5 is up there, and now, look at that, it doesn't pass the vertical line test anymore. So, not a function anymore. All right, so that's with points. And then what's the last way, if I give you this, a crazy function, that you can tell me if it's a function or not. Can you tell me if that's a function or not? You can't just say it's a function or it's not a function. You have to prove it. So how would you prove it? Yes? Solve for y. Very good. What if you do solve for y and you get y equals 6x squared minus 12x plus 7 or whatever? How do you tell if it's a function or not if it's solved for y? Yes. If it only has one rule like this, then it's a function. But if you get two answers, y is this and y is that, if you get two different things, like two different answers for y, then it's not a function. If it only has one y equals, then you're fine. So what's the key there? If it's y squared, do you get at some point you're going to have to square root that? And do you get that's going to cause an absolute value? And that's going to cause you to have two equations. All right. So bottom line, this, would it be a function or not? It would not be a function. Because do you get at some point you're going to have to take the square root of that y squared? And do you get that that means absolute value, which means two equations? All right. That's the three ways you can tell if something is a function. Another topic. You know what? I want to go back to one of the ones that we did earlier because it was the hardest, newest thing for you. So just tell me if I had this function, what it would f of x plus h minus f of x be? I'll pause while you give that one a try. Okay, let's see how you did. X plus h goes right in here. 7 times x plus h. Square it, and then minus 3. So then it's 7 times x plus h, x plus h. Please don't ever think it's x squared and h squared. Just split it into 2, because there's more to it than that. There is an x squared, but there's also an xh plus another xh. So I'm going to rewrite it down here is 7x squared plus 2hx plus h squared, and then I bring in the minus 3. There. Something tragically wrong right now. Yes, sir? Parentheses. Parentheses actually ended where? After the h squared. Okay. Now I've done this part, and it's all in a parentheses, and I'm going to times it all by 7. 7x squared plus 14hx plus 7h squared. Then I can subtract 3, and then I'm done. No, I'm done with the first part. Now I got to subtract f of x. So I go minus 7x squared minus 3. Wrong again. What did I do wrong there? Parentheses. Need a parenthesis around this because that's like a variable right here. That's like a y, and you drop a parentheses in, and you drop it in the parenthesis. And then the negative 7x squared will cancel the positive 7x squared. The negative 3 makes positive 3 here, cancels this negative 3 there. So all that's gone. Final answer, 14hx plus 7h squared, and that can be reversed. How many of you had it right? Okay, good. Any questions? Yes? You can factor it. I like factoring, but you're not required to in this situation. The guideline is generally this. Factoring is especially handy at the beginning of a problem, because then if you factor it, a lot of times you'll see, oh, things will cancel, or, oh, I can see my answers are right there. At the very end of a problem, you don't usually need to factor it at the end. But sometimes you catch that, oh my gosh, now that I factored it, I see something else cancels that I didn't notice before. So yeah, you can factor it, but you don't have to. All right. We have done pretty much everything that you would have to know for the test. Now, I did separate off some homework problems and put them in this file because last night I only assigned you a couple pages of the homework. So I want to talk through a little bit of what the homework would be for tonight. It is, you do not have to do these purple ones. You can cross those off. Why? Because they mix in a and, like a is greater than 1 in with this function. It's not really that hard. It's it's kind of cool, but it's a stretch and it's not something, it's too hard considering you have a test tomorrow and I want you to focus on a lot of things. So you can skip the purple page. This page is good and this page is good. Those are the two pages I want you to do. All right, so on this, think about a volume of a cube where one of its sides is x. Well, if one of its sides is x and it's a cube, what do you know? All of them are x. Then why would they say x has to be bigger than 0? Because to be a cube, you have to actually have a side, and that has to be bigger than 0. So, right? So that's a domain. The point here is just that this technically is a piecewise function. Do you get that it's got a function, but I don't do it on the whole graph? Really, if I were to graph that, it's only going to, even though x cubed looks like this, only one of those areas works in the real world. You can't have negative sides, so that doesn't work. So it's like a piecewise function. It only works in certain part. This part is not possible in the real world. All right, so by the way, when it says interpret your answers to each, it's just like when you get an answer of 6.3, we want you to say, what does that mean? 6.3 what? What's the context of the question? All right, so whether they wanted to find V5, that would be the volume if you had a side of 5, right? So that's interpreting your answer. So if this was my answer, I would say this is my volume. Or I might be able to put units on it and say that it's in units cubed for volume. So that's all we mean by interpret, is not like you write a paragraph. It's just like, what is this about? Okay, the next one. Why do you think when you drop an object off a building that it only really works for time between 0 and 2? Yes. You can't have negative time. Yes, that's why it has to be bigger than 0. Why does it stop at 2? Shouldn't this thing that you drop off the building just keep making that same parabola shape forever? It's going to hit the ground, exactly. When do you think it hits the ground then? Oh, it doesn't depend. It tells right in the problem. When? When does it hit the ground? It must be at 2. Okay, so as soon as it hits the ground, then its graph looks like this. It doesn't move. It stays on the ground. Okay? So that's why, again, this is really a piecewise function. It's only going to work in this little zone between 0 and 2 is where you have this graph. All right. So, and I want to warn you, the homework is pretty much all R3 type questions. If any of these were on a test, this is an R3 as in a hard question. Not impossible, but there's only 4 of them for a reason, because they're challenging. So this graph, it's 15n if you're between 1 and 25. That means, in the context here of the book, Me and My Sasquatch, by the way, there's a free textbook, online textbook, and it was written by guys on the east or on the west coast, up in northern, like north of California, where they have Sasquatch sightings and stuff. So of course that's why the Sasquatch obsession is here. It's because the free textbook we have was written by people in like Olympia, Washington, or wherever. So they're saying that they'd sell these books to you for $15 each if you buy between 1 and 25 books. Do you get, it makes sense if you buy more books, the price drops? Does that make sense? All right, and if you buy a whole bunch of books, like more than 50, then you can get them for $12 each. So this is another context for a real world piecewise function. That actually happens for real. It happens on taxes too. Do you get that the first like few $100s you make, you don't have to pay any taxes on at all? If you make, I think the number is $600, you don't even have to report it at all. If you make $600 or less, then the government doesn't even see that you ever made anything. Okay, but if you've got made more than $600, then you start paying a certain kind of tax, but you pay a very low tax rate until you hit like, I don't know, 10 grand or something like that. Once you start making 10 grand, then they start charging you a little bit more for your next 10, 20 grand. And then if you make a lot of money, there are some states in the United States, California being one of them, where if you make a lot of money, between the state and the federal and everything, you pay more than half your money in taxes. More than half. True. In the United States, 50% tax feels like a lot. In other countries, like in France, they raised theirs to 75%. You have to pay the government 75% of what you make. On the other side, they give you lots of free things, get free health care and that kind of stuff. But anyway, don't mean to get into a debate of whether that's smart or not. I'm just saying that there is definitely strata. Like here, you're only in your taxes. If you only make between 1 and 25, let's say 1,000, you pay less tax. And let's say this is 25 to 50,000. Now you're paying more tax. And you're making over 50,000. Now you pay an even higher tax. And we have tax brackets like that too. So that's also a piecewise function. All right, so this last one here, comic book retailer, same thing, where they are saying that this is your deal if you buy between 14 bucks. But they're going to charge you nothing for shipping if you order 15 books or more. Get how that's two different graphs? If I graph the one, your price could be going up until you hit like 14, and then all of a sudden, your price goes to 0 if you buy more than 14 books. Okay. That's enough for you to do for tonight on piecewise functions. The rest of your time should be spent maybe going back and doing any problems we skipped, making sure you're ready for the test tomorrow. And that's all I got for you for today.